All right, Phil, what are we doing?
Oh, what are we doing? I think we are going to be talking about the GTMore engine and what all is going on with that thing and how we were able to make 800 wheel horsepower reliably out of it. But really, as I'm thinking about this, I'm reminiscing on all the stuff we've done with this thing. I mean, gone out west, trip around the country, broke some records, and developed a ton of stuff off of this car to help the entire F8X platform. So really for right now, we're gonna dive in on the engine, the power, the cooling, the turbos, all the stuff that makes this thing go vroom. All right, let's get into it, buckle up. I'm about to throw a lot of words at you on this engine project. So we started with a bare block, brand new bare block from BMW, just to make sure that we had a good core starting point for this engine. We had a few different engine cores floating around, but just wanted to make sure we had no issues, brand new one. So I went with a bare block, and then from there, added on some of the goodies. And to start with, we went with Mala Power Pack pistons, and one of the awesome things about Mala is that they are a factory BMW supplier and have been for a ton of years. So you're able to get that factory OEM fit, reliability, consistency from an aftermarket supplier for a performance product. Pretty awesome, love that. And these things are a lot stronger because the factory pistons are cast and these are a forged construction. So the inherent grain structure of the piston is much tighter, stronger, more durable to take the abuse that we're gonna throw at this thing. They're also coated for increased protection and reduced friction. On piston install, a common question is, how do I gap my rings? And on this thing, we went with a bit looser ring gap because we know this thing is gonna heat up quite a bit. And if you go with a tight ring gap, when you add that heat, add that pressure, add all that force, those rings can tighten up if you don't have that gap just right and cause an issue. So went with a bit looser ring gap here. Then next, you got to connect those pistons to the crank, so you got connecting rods. And we went with CP Carrillo connecting rods. They are an H-beam design, these big beefy things to just take a ton of force as that explosion in the cylinder is hammering these things down. Really stock connecting rods are probably good for, I'll say a number and someone will contradict me, but I'm gonna say 600 wheel torque. And you could go up or down on that depending on tune and whatever, but we're gonna abuse this thing. This isn't like a dyno queen or a drag strip just doing a quick pull. This is constant abuse on track. So we really needed something that was reliable. Those connecting rods are heavier than stock, which, you know, typically with an engine, maybe you want something a little bit lighter, let it spin freer, spin faster, but we really needed the strength. So okay with sacrificing a little bit of weight to get that reliability and durability out of those rods. And then there's two options on connecting rods for the CP rods. There's WMC bolts or CARR car bolts. The car bolts are for super high power applications. For what we're doing with this, while it is high power for a track car, the WMC bolts totally good, so we went with that option on this one. We did WPC treated rod bearings, and WPC treatment is something we've done with rod bearings for a lot of years, and that helps reduce friction, helps oil stay retained in those bearings to help keep it protected and just help take the abuse. We also hit the nemesis of the S55 engine, the crank hub. A lot of people think you don't need to do it. A lot of people think it's a must, you have to do it. There's varying opinions all in between. When you get to this power level, I'm gonna do it. And we went with the SSR 4-pin crank hub solution. The crank hub problem is that there's no keyway, you know, on old engines you call them a Woodruff key, but there's no keyway to keep that crank timing chain locked in place. It's all just based on friction holding this crank hub system in place, which means that at big power level, you have a chance to spin that sprocket that holds the timing chain, lose timing on your engine, maybe bend a valve, maybe have a bad time. But that SSR 4-pin crank hub solution, you drill into the crank, these pins get in there. It's got another keyway on it as well because there's two sprockets on it, the oil pump sprocket and the actual timing sprocket. And then it keeps everything as a safe measure locked together to reduce that chance, eliminate that chance of spinning the crank hub. So did that in this thing so that we don't have that problem, because at this power level, you're gonna want that peace of mind. Another point of reliability to hit is our oil level sensor spacer kit. Why do you want that? Well, at its core, it allows you to overfill the oil, which is going to help keep more consistent oil pressure under those high G scenarios. And it sounds kind of counterintuitive because you're going to put a spacer to lower the oil level sensor. Wouldn't that mean that the oil level is going to read lower? No, it's actually going to read higher because we also include the correct oil level sensor that is longer than the stock one, but you got to get that sensor into the sweet spot so that it doesn't run over the crank. If you were to put that long sensor into the oil pan without the spacer, it would hit the crank, be damaged, not having a good time with that oil level sensor. But really, that's a key piece to help maintain oil pressure, especially with these 315s, big aero, all the things, big grip, big G's. That's pretty much the bottom end, the core of it. On the top end, the head, Vanos is an amazing thing. Some people asked, did you do cams on the thing? No, we didn't do cams, but the Vanos in these modern engines, you can just tweak the cams and dial them in to really get what you need out of it, unless you're doing something absolutely nuts. We did, however, do MILVs. No, I didn't say what you think I said. What's so funny, Rich? Modified intake lift Valtronic supports. I got that right. And what those do is they basically help change the lift on the intake cam. It adds about 1 millimeter of lift or 2 to 3 degrees of duration on that intake cam, which in turn gives you more power per PSI and just helps that engine breathe a little bit better because we are flowing a lot of air through this thing, a lot of power through this thing. So that was pretty much it on the head. Other than that, stock and threw it together. Now, let's force some air into that baby. So turbos, we've actually tried a few different turbo options on this thing. We've done stock. We had a prototype set of turbos from MHI, Mitsubishi, also the factory manufacturer of the turbos on this thing. And we were really looking forward to that project for those turbos because they were in a real sweet spot for what we think is a great turbo for a track car. That project didn't end up panning out, which was a big bummer for us. However, our friends at Pure also have some pretty awesome turbo options, and we ended up landing on a Pure Stage 2 Plus for what we were doing with this car. A Pure Stage 2 Plus can flow a lot of power and a lot of air, but we kind of found that maybe that wasn't the ideal scenario for every track that we went to. You know, big flowy tracks, Watkins, Road Atlanta, VIR, where they're pretty fast, pretty good turbo. However, Pure also has some other options, the Pure High Flow, that's more of a mid-range between the stock and the Stage 2 Plus, that if you're going to some smaller, tighter tracks, maybe it's a little bit better, it doesn't have quite as much turbo lag. But those Pure 2 Pluses have been holding up great on this thing, and I mean, we've made 800 wheel horsepower, so pretty tough to complain about that too much, especially on some of those big, wide open tracks. God, did I go through that backwards? It's fueling and then I go into... So all that air, you gotta have fuel to go with it, and I'll tell you what, this thing's pretty thirsty. It drinks some fuel, and some of the system's components we have in place to help it drink that fuel. To start with, at the injectors are S63 EU5 injectors, a pretty common upgrade as a stage 1 point to upgrade. I think they increase fueling capacity about 10 to 15%. And then we added a Dorch Engineering high pressure fuel pump lift kit, which makes it go to like 38% headroom increase. You know, if you ever look at a data log or understand the high pressure fuel pump side of these things, that high pressure fuel pump is pushing over 3,000 PSI of fuel pressure to the rail. It's a ton of pressure, and it takes a lot of fuel to feed this thing. And you do also need to make sure that the low pressure fuel pump in the tank is feeding that high pressure fuel pump at the engine properly. We actually did not upgrade the low pressure fuel pump in this car because we kept it on regular fuel, gasoline, instead of going E85. If we were to do E85, we absolutely would have needed to do a low pressure fuel pump upgrade because the fueling demands are increased so much when you go to that. We kind of wanted to keep it with something that was available at the track.
Who's that guy?
110 is at the track, 100 is at the track, 93 is at the track. E85 is not available from the pump at the track. Yeah, okay, we could have taken some E85 with us to the track, but we wanted to keep it simple and go with what probably most of our customers are going to be going with in this type of build. We had 93 tunes for situations like One Lap of America where James and Evan were driving all across the country and needed to be able to put whatever fuel in this thing.
In Texas, at least, they have brisket on tap, so we'll see if that's the deal here.
We had VP Racing MS109 fuel, which is actually not 109 octane. That is a 104 to 105 octane, but it's an unleaded fuel, which we were required to run an unleaded fuel for grid life when we did that event with this car. And then for a lot of the uncorked stuff, we used 110 leaded, just because that actually is 110 octane. Give us some more headroom, give us some more octane, give us some more power. So that's the fueling side of things. We've got fueling, turbos, engine stuff. What's the next piece to make all this work? Tuning, software calibration. You can't have all these hard parts and then not have the software to make it work. So our friends at Motive Tuning, Chris has been awesome on this project and has provided all kinds of tune files for all kinds of fueling. As I went through, we've done various different turbo setups, we've done various different fueling options, and each one of those really requires some different tuning calibrations. And I can't say enough for the ability to keep this thing reliably running at all these different power levels and different fueling options. So thanks to Chris at Motive for helping us out with this project. You got all this power, this tuning, this fuel. When you have more power, what do you produce? More heat. There is no way around it. You're gonna produce more heat. So we had to keep it cool. And we've got various different cooling tricks that we've done on this thing, but at the core of it, that CNR PWR top charge cooler, that top mount intercooler was really the key piece, as that is an incredible core from PWR and actually really makes a difference because you gotta keep those intake air temps down. Along with that, there's a CSF front mount heat exchanger for increased capacity. Also has a nice little port on the side that we were able to modify to make a bleed option so we could bleed that whole intercooler system. Then there's another cooler on the right side that we got from PWR for the intercooler system. So that's 3 coolers just for the intercooler system to help keep those intake charge temps in check, because if you want to go beat on this thing at 700 horsepower for 20 minutes, you got to keep it cool. Then there is another aux radiator on the left side from PWR that we put in this thing. There is oil cooler, all kinds of stuff, but all knocked out in this thing so that we can run this thing reliably in California heat, road Atlanta, middle of summer, 100-degree high humidity heat.
Yeah, well, it's hot.
All the things that we were able to accomplish with this thing and run it reliably, keep it cool, keep it in check. Really impressive as I just run through that entire list of all the things that we did to the engine, cooling, power components of this that, gosh, do we really have to get rid of this thing? It's kind of amazing. I guess we do, because we got to move on to the next project, but love this, love all the components. Thanks to all the partners that helped us put this engine and cooling package together to make it as reliable and powerful as it is. And if you want to help make your F8X reliable and powerful, check us out, BimmerWorld.com, hit us up, here to help guide through any questions you have so you can put some of the GTMore recipe to work in your car.
You ready to go? Should be an awesome race weekend. We are ready to kill it this year. It's good. It's going to be a wild ride.